Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. Hey everybody, in this video we're going to translate between explicit and recursive rules for geometric and arithmetic sequences. So part one, we're going to go from explicit to recursive, so let's review that process. So for arithmetic, our explicit rule is a sub n equals a sub 1 plus n minus 1 times the common difference, where a sub 1 is our first term and d is our common difference. Now for recursive, we need to list our first term, and then our rule is a sub n equals a sub n minus 1 plus d. So we'll come back to geometric. Let's go look at number one, where we're going to use arithmetic. So we see we have a sub n equals 30 minus 5n. So we could also write this as a sub n equals negative 5n plus 30. And so a different way to write it, but essentially it's the same thing. And now for explicit, we need to realize that the coefficient of n is our common difference. So in this case, d is equal to negative 5. Now 30 is not my first term. Okay, we need to realize that. If we think about this, it almost looks like slope-intercept form, right? mx plus b, negative 5x plus 30. So if we think about it in that way, if it looks like slope-intercept form, 30 must be my y-intercept. Well, my y-intercept is when x is 0. Or in other words, that would be like the 0th term of my sequence. And we're looking for the first term. So if the 0th term is 30 and my common difference is negative 5, then our first term must be 25. Well, let's see how we can prove that. Well, we need to find our first term. So a sub 1 equals 30 minus 5 times 1. So it would be equal to 30 minus 25, 30 minus 5, which is 25. Right? And so now we know that a sub 1 is equal to 25. This is important. Our common difference is negative 5. That's important. Now we have the information we need to write our recursive rule. So we're going to write a sub 1 equals 25, comma, a sub n equals a sub n minus 1 minus 5. And that would be our recursive rule from the explicit rule a sub n equals 30 minus 5n. Now for number two is geometric, so let's take a look at our geometric explicit to recursive rule up here at the top. So it says a sub n equals a sub 1 times r to the n minus 1 power. That would be our explicit rule for a geometric sequence. And our recursive rule, once again, we're going to list that first term. And then our rule is going to be a sub n equals r times a sub n minus 1. So it's very similar format, not as much reworking the equation as there is for arithmetic sequences. For geometric. So when we look at our geometric sequence, 7 right there, that is our first term, and the number that's in parentheses, that is our common ratio. So really that's all we need. So we can write a sub 1 equals 7, and then a sub n equals 2 times a sub n minus 1. And that'd be our recursive rule from the explicit rule for number 2. Now part 2 of this video, we're going to actually go the other way. So now we're given a recursive equation and we want to write it in the explicit form. So we're not going to go over arithmetic and geometric. Again, it's the same exact two equations we just looked at, but flipped, right? So for number one, we have a sub 1 equals 7, and a sub n equals a sub n minus 1 plus 4. So we see the plus 4 there. That tells me it's arithmetic. And so we see our first term is 7. We have our common difference, which is 4. And now we can plug that information into our explicit equation. So a sub n equals a sub 1 plus n minus 1 times the common difference. So a sub n equals 7 plus n minus 1 times 4. Now I'm going to distribute this 4 to the n and to the negative 1. So 7 plus 4n minus 4. And notice here we have a 7 minus 4. So our final explicit rule would be a sub n equals 4n plus 3. All right, so that'd be the explicit rule from the recursive equation. And number 2, we have a sub 1 equals 5, and then a sub n equals 6 times a sub n minus 1. So we see that multiplication there. That tells me it's geometric. So now we're going to write a sub n equals our first term times our common ratio, and then to the n minus 1 power. Okay, so like I said, geometric, not as much involved as arithmetic, but that is how you can translate between recursive and explicit equations.